Okay, and now my exotic standard has opened. What I like to do first is to copy it to my drive because I find it more convenient. So I've copied it to my drive. And the next thing is click this icon, icon below to run the code for each step. Okay, we have 4 steps. We have step 1, step 2, step 3, and step 4. And this step 1 will take estimated 2 minutes. Okay, this step will import required exotic libraries, and then it will connect your Google Drive to access your fit images. So this is the icon. We're going to click it. You know, this exotic program was written with a Python programming language. So it is going to begin to import those libraries that we are going to need to perform photometry, I mean automatic photometry on our images. So loading starts, please wait. It's coming. Oh, I hope it is not going to crash. However, I do hope it crashes so that you can see that crashing it's normal. It is not that you have done something bad. Crashing in this project, I mean, it's normal. Okay. If it crashes, you click it again. It will be okay. So let's see how it turns out to be. This will take a minute. Please wait. Oh, it has the session restarted after it. Oh, your session crashed for an unknown reason. Okay, it has crashed. What we do is we run it again. Run it again, and this time, believe me, it might work. It's normal, basically normal. Okay, we have the NASA Exoplanet Archive, AstroPi. Oh, it's coming. Yeah, I think it is successful. Permit this notebook to access your Google Drive files. Okay, connect to Google Drive. Let us connect it to our Google Drive where we have our images. So this is my email. Okay, continue. Click on continue. Then if you come over here, Google Drive for Dex already has some access. See 8 services that Google Drive for Desktop has some access to. So if you have opened it for the first time, I've opened this before, but if you open it for the first time, there is a section where you have to select all, okay, so that you can connect it to your computer. I mean, if you're doing this for the first time, but if you've been doing this over and over again, you don't need to, you're going to see this, okay? So that is why it is telling me Google Drive for desktop already has some access. So because I have been using it before, so I will just click continue, and it will be connected. Let's watch. Okay. Okay, drive successfully mounted. Say done, mounting Google Drive. You may move on to the next step. And if you come over here, you will see a mark, green mark, indicating that this step has been accomplished. So you move over to the next step, which is step 2, load telescope images. Okay, this will take 1 minute. This step will prompt you to type in the path of your fit files on Google Drive. I'll prompt you to type in your AAVSO observation code if you have one. So how do we do that? You come over here, you click, then you click on Drive, click it once, click My Drive, then you choose, we loaded these two images before, so we're going to choose the one we'll perform first. Maybe we should work with Trace 3. Okay, let us work with Trace 3 first. I think Trace 3 is the one NASA gave to us. You click on it once, then this is the images. So this is the docs, and these are the rest of the images. So you come over to this Trace 3 folder, see these three dots, you click it, then you come over to copy path, then you copy the path. Once you've copied the path, um, okay, then let us click on load images so that we can paste the path there. So say enter path to fit images, and so let's paste it. Control V. I've pasted it, and then you click enter. Once you do that, please enter the name of your exoplanet target. Enter the name of your exoplanet target. So because of the path, we are working with Trace 3, so the name of the planet will be Trace 3b. Hope we write that correctly. Trace 3b. Moment. Trace 3b. Then click enter. So it will go over to the NASA archive to fetch data for that exoplanet. So it is correct. So this is the target star, the right ascension, the the declination. The planet's name is Trace 3b, and this is the host star, which is Trace 3. We're going to need this again. Then it will prompt you to enter your observation code, like we have generated it before. If you can remember when we generated this code, MMAPA, you should always memorize this in your mind. So I'm going to enter it, MMAPA. Click on enter. It will prompt you to do that again, MMAPA. So you may move on to the next step. So we are done with this step. Let me close this. Then clean image. Let's see what this is all about. Let's run it. Clean images. It's optional from what we can see there. Would you like to manually clean images? Image quality, yes. Let's enter. I typed Y, and clicked on enter. So these are our images, 69 images. Okay, so there are 69 images, and this is just the first one. Okay, and here you can clean it up. You can remove the bad ones and retain the good ones. Even if you do not want to do it, Exotic is going to do it automatically for you. But it is advisable for you to do it by yourself, because the outcome, the light curve, will be more improved if you do it by yourself. So I'm going to okay, there is nothing wrong with this one. This is clear. I will click on keep. The second one will come up. The second image, okay, it is okay. Keep. So you have to keep inspecting images for the bad ones. These ones are good ones, okay. For the bad ones, they will not be as clear as this. I mean, if you see a bad image, you should know, even without having an experience. So click, keep clicking, keep checking, okay, until you check the whole, or maybe you check about the first 20, or you check all of them. You know, we don't have much time for that. So, but I would advise you to check. If you see any bad image, you always have to remove them. Then here is identify target star and comparison star. So this will take 3 minutes. Okay, this step will prompt you to type in your star chart image, ask you to identify the coordinates of your target star and comparison star. So how do I get a star chart? So we before we click on this, we have to type in the star, the name of the star. The name of our star is Tres 3. So I like to come over here to copy and paste this one. So that we can fetch the star chart. Copy, come over here. I will delete this. So the telescope is the micro observatory, of course. That is where we got this data from. Then you come over here and you click. The exotic is going to go over to the AA, American Association of Variable Stars, and fetch the star chart of the star. I'm going to use it to pick your target stars and the comparison stars. Okay, it's almost done. Oh, so fast, and the star chart is coming up. The name of the star is supposed to be here, but this is another. This is a similar name to that. So we will begin to. Um, we're going to use our pattern recognition skills to be able to identify the target star. Hello, hello. Before we go further into exploring this, I would like to remove this hover over my mouse so that my mouse will remain. So what you're seeing right here is the star chart. Okay, it is going to guide us into identifying our target star. And by the way, if you look at this, if you look at these two charts, you won't see any exoplanets, orbiting around the any hot star. But this is your images. Okay, it contains the star field around your target star. Okay, it contains the star field around the target star. So among all these stars here is your target star, and because several images have been taken of your target star at different time intervals, maybe in seconds, after identifying your target star around the after identifying your target star, we're going to perform the photometry. The exotic program is going to help us to perform the photometry, and you would see the light curve, okay, to be shown from your light curve. So from here, your target star is always at the center, but your target star is not always at the center here. Uh-oh. Okay. Your target star is always at the center here, but not at the center here. So it can be located at any point on this image. Okay. Also observe that there are some numbers attached to some stars. Okay, those are stars with known brightnesses, and they are called comparison stars, or you can call them com stars. So we're going to identify the coordinate of our target stars, and also that of these com stars from here. And to get that, you have to know how to use some of these tools. The most important are these ones here. This one is the wheel zoom. So if you are using an external mouse in your computer and you want to zoom in, you have to click here. Once you click that, you can zoom in with your wheel mouse at any direction. I'm using the wheel mouse and I prefer using the wheel mouse. Okay, if you want to return, maybe after messing up the whole image, you want to return it to its default mode, you can just click on reset. But if you do not have a wheel mouse, you can come over here, box zoom. If you click it, let me unclick this one. If you click it, you can just come at any point of you want, and oh, let me do that again. Reset. I've clicked the box uh, zoom, I can just crop, okay, to zoom in into that region. So having understood this, let me activate this. But if you have the other one, you can just use it. Now reset. Having known this, we're going to deploy our pattern recognition ability in the ability to identify patterns. For instance, if you look at these three stars, you can identify them here, these three stars. Okay, that means these three stars are similar to this one, so that is good. If you also look here, 1, 2, 3 stars, you also see those 1, 2, 3 stars. So there are so many patterns you can identify here. So knowing this, our target star is always at the center. Okay, so can we identify some structures like this from our image? Because they are very close to our target star. So if you look very well around the grid, everything, okay, if you look very well, oh, look at that, you would notice that this region is looking like that. That means our target star could be around this place. So I'm going to zoom in. If I zoom in, I would see the whole stars clearly, although I cannot see the exoplanet orbiting it, but just the stars alone is okay. So I can identify these three stars here. I can identify these three stars, these ones. So if I look further out, I should be able to see a target star. And if you notice, this target star in the chart has no star attached to it. But in your real image you obtained from the observatory, there must be a star attached to it. So let me zoom further. So this is the brightest star there, this is the brightest star. If I project straight, so if I project straight, I think this should be my target star. And if you observe, there is a number x and y in the x and y coordinates. So I'm going to write that out. That is why I said you should keep your pen and paper close to you. So the x coordinate is 208. I mustn't take the decimal part. I just want to take the whole number part. Then the y coordinate is 218. So I have identified the coordinate of my target star. So let me go ahead to identify the comp stars. The comp stars, okay, that big star is a comp star. Okay, look at it here. It's a comp star. And what is the coordinate? So this is my first comp star. The coordinate in the x direction is 167 and the y is 200. So that is for my comp star 1. I need another comp star. Okay, this star closer to my target star is also a comp star according to the chart. So I'm going to put it there. So my S coordinate for that comp star is 192 and for the Y is 225. So I should keep on identifying as many comp stars as possible. But for the exotic, you will need a minimum of 2 comp stars and a maximum of 10. But because I'm recording a video, I don't need to show you how I got all the comp stars. But I'm just giving you as an assignment, you can go ahead to identify as many comp stars as possible. And so after identifying these comp stars, you come over here. Oh, you come over here to enter the number. So enter coordinate for target star in the format and press enter. So let us enter the, the, the numbers. So I can begin entering the numbers. So remember x before y, okay? So you put the numbers 208, comma 218. Okay, then you enter. This is for my target star. Okay, you enter first, then it will bring you another space to enter your comp stars. If that does not happen, you can come over here and rerun this. Rerun this and maybe enter the numbers again. It's going to come out. So it is out again. So I'm going to enter it. Oh, it is still booting, but I'm just going to enter it. 208, 218. Oh, that's come out. So I'm going to enter for, look at it says enter coordinate for the comparison stars in the format. So this is the format you must enter that. You must obey this rule. So I only got two stars, but maybe you may have more. So I'm going to open the bracket. Okay. Okay, two. Maybe I should just two. Then I have 167, 167, comma 200. So you close it. Then you put a comma to enter the second one. You open it. 192, 192, comma 225, 225. Then you close it. I'm done entering my stars. Then you close the entire bracket. Then you click enter. One thing about comp stars is the more the comp stars, the more your the accuracy of your light curve. You may move to the next step. So we are done with this step. So run exotic to generate a light curve. So this is the part we're going to perform the real photometry. You're not going to perform it because this is a Python program which has been written to do that automatically for you. So you don't need to stress yourself doing that. So let's run it. If you want to see the code, you can just click here, but I don't think I want to do that. So click, begins to run. It will take some time. It will take some time, and I'm not going to show the whole process. Would you like to the light comparison start added automatically for yeah, so yes. So it begins to run. Starting reduction process is going to take a whole lot of time. So at some point I'm going to cut this video, then I will show you the final result. So I'm going to stop the video here and show you the final result. But at this point, you just have to let it until it finishes. It will take some time. So the task has completed, and let me walk you through the whole process. It's quite a long process. It brought a lot of lines. Okay, you mustn't understand what they mean. Okay, you mustn't understand what they mean. So you brought all these things. Let me go back, and you brought out the light curve for us. You brought out the light curve for us. Let me show you the light curve. Okay, and this is the light curve, and this is the field of view of the star. This the star field of the star with the exoplanet. I mean the TRES-3 is the star, and TRES-3b is the exoplanet. This is the light curve showing, and these points are the data points from each of the images. Okay, and the red line is the line of best fit. So here it means that if you multiply this by 100, it means that about 3% of the brightness of the whole star was covered during this transit. This is the mid-transit time, and this is the baseline. So this is a pretty nice light curve, and these are other information. Then you don't need to download the data. I will show you where to do that. So you go to your drive. This is where we uploaded those three images. If you remember, those two images, sorry. This is for the TRES-3, and this is for the WASP-10, but we worked on the TRES-3 right now. So, and this is the output. This is the output. These are the things, the data, the exotic generated. So you can go in to see the other files, documents that are in there. You have, this is the init.json. Okay, and this is the final light curve, which I told you need not to download from there, so you can download it from here. So this is the light curve, very beautiful. You can submit it, you can share it with, on your social media. You can share it at the NASA Exoplanet Watch community to be shared up. Then this is the text you're going to submit. Okay, let me download this. They're going to submit this to the AAVSO. And then one other thing is this temp folder. Oh, the temp folder contains other documents. Okay, you mustn't really understand that, but let me walk you through this FOV. We're going to submit any of them. We have the PDF and we have the PNG forms, but we want the PDF. So let us view them one after the other. So this field of view is just simply the star field. Okay, so you have to look for the best ones. I mean the one that has the best picture. Okay, this one is good, but let's check other ones. Okay, this is good too. Okay, maybe oh, this is bad. Okay, we can't submit that. This is uh this is bad. This is not too good. This is not too good. Oh, this is good. This is good. And this is good. So this is the square stretch is good to submit. So let's check for this the square stretch. The square stretch. I'm going to download the PDF. Okay, I'm going to download the PDF of the square stretch. So because I'm going to submit those two. So if you go to your download, you should see those files. Now you come over to your exotic, then you click on submit light curve to exoplanet watch via this, so that we can submit those files we have downloaded. Yeah, click there. It will bring you to the exoplanet database submission. So here is where you will submit your data, those data that have been generated by the exotic. So here is the report form, the document, and here is the space to upload the one of those images, I mean the field of view. But then you have to also, if you notice, there's no site, the telescope site where the images were taken. We don't have any information about those, uh, about them now, and also the equipment. Okay, it is empty. So we need to fill this first. And to fill that, you come over to Site and Telescope. You click on Site and Telescope. So here is where to fill uh, the site and the telescope. This is the site, and this is for the equipment information. Okay, after that you click on Save. But where do we get the information? We're going to click. You're going to enter there. So to get it, you come over to the link I provided. the exoplanet research links. So you come over to the exoplanet research project. We want to get back to the NASA website. So this is the NASA website, okay? Then come over to how to get started. I want you to follow my instructions so that you don't miss it. How to get started. Then come over to getting started, troubleshooting, and problem solving. You click it, then you scroll down, okay? Then you are going to find those information. This is for the site, okay? For the site, these are the information you're going to enter. My site name is Micro Observatory, okay? Then this is the latitude. You can't, okay, I think I can, okay, let me, north, latitude is north. I'll go back to that. So add site, okay, Micro Observatory. Let me copy that again. Micro Observatory, open. Then I'll enter it here. Then the latitude in degree. It's already in degree. The latitude, I'll copy, paste it here. Then the longitude, sorry, this is the longitude. You come over here. Then the altitude is this. You copy it, then you paste, then you save. It is saved. So the micro observatory. After saving that, you come over to the equipment side. Uh, my equipment name. Let's go back. Oh, sorry. Oh, yeah. So my equipment. Select the equipment package. Okay, let's check that. Add equipment. I think it's micro observatory. We've done that before. Let me copy that again. Micro observatory. Copy. Paste here. Then type CCD, telescope, binoculars. Any information about this? Okay, aperture is 152. Aperture is 152. 152. And the other one is 560. Focal length is 560. 560. And camera characteristics. Okay, camera characteristics is okay. Just enter these numbers because I wouldn't like to um, start wasting time. I want you to just enter these numbers over here. I'm going to cut this video, and after entering those numbers, okay, you click on save. So I'm going to cut this video and show you where I have filled all of them so that we don't need to prolong the video. So I have finished filling the spaces and look at the information that I filled in there. So in case if you do not get some of the numbers, you can look at this. This is 15.000, okay? This is 15.0000. Okay, so after that, this is capital CV. After that, I clicked on save. So, and I have this equipment has been added. So to get back to your page where to submit it, you come over to submit light curve. You know, you can click there. Okay, just click it again instead of just going back. Just click it again. So if you click it, okay, to take you back to that page, so you can submit it. And now you have those some sites, select sites information. Okay, select equipment, then report form. So let's submit our report form. So go to downloads. So this is the text file that I told you. This is the report form. Okay, click it, open. Then image. Let's submit the image, field of view. Then You click on accept the GDPR. Then you click on submit, and your light curve will be submitted. Upload successful, and this is how you do it. Then you go over to keep analyzing more images. And please mind you that this information, the data that we are working with are all obtained from the micro observatory, both the ones we got by ourselves and the ones we got from NASA. Okay, they're all gotten from the same micro observatory. But in case if you are using your own telescope, okay, the site information is going to change and the equipment information is going to change. So in that case, you have to open it again and also enter for the site and the equipment that you are using. So in the next one, we will analyze another one for the WASP-10, and so that we can have a full knowledge of it. Thank you.